Okay, welcome to the practice structural dynamic simulation. Let's take a little bit of review of what we get here. Until now, we explained the equations of motion, where n plus 1, bn plus 1, dn plus 1 are the response of n plus 1 step, with the input ground motion of ag n plus 1. And vn plus 1 can be get from the step-by-step integration using information of n steps vn and an and n plus 1's acceleration. Based on Newmark beta method, we can also calculate dn plus 1 here, like this equation. dn is the n step of displacement. Other part are the incremental part. Bn plus 1 is incremental due to the velocity of n step. This part, n plus 1, an, half an delta t squared, is incremental due to the acceleration of n step. And this part, beta delta an plus 1 delta t squared, is incremental due to the change due to the acceleration of n plus 1 step. And we inserted them into the equation motion and put all in things related to n plus 1 in the left side of the equation, put other things to the right side. And finally, we can get a shorter version of the solving an plus 1 by this equation, f hat divided by m hat, where m hat is constant value and f hat is updated step by step. AV and A as constant value for the Vn and n term is also constant value. Okay, this time let's try something new. We know that this equation works for the n plus 1 step, so it was also work for the n step. By doing the substitution for these two equations, we can get their differential type of equation, where we define delta an plus 1 with delta vn plus 1 and delta dn plus 1 like they're incremental. And we can get this incremental shape of the equation of motion, in where delta n plus 1 is equals to vn plus 1 minus vn, so it becomes of an plus 1 and n delta t, the incremental due to the acceleration of n step, and half delta an plus 1 delta t, where is the incremental part due to the incremental of the acceleration in n plus 1 step. Same time, we can get also dn as same. We're just ignore the dn term for the dn plus 1, and we can get vn, an, and delta n plus 1 term. Use beta here. Okay. Let's instead of delta vn plus 1 and delta dn plus 1 into the equation of motion. Just like this. Put this part into here, and put this part into here. And we get this kind of equation. Now we realize only delta n plus 1 is only unknown term. So we put everything about delta n plus 1 in the left side of the equation, and put other things in the right side. By collect all the things about the n together, equation will be changed like this: c delta t, k delta t square, an, and k delta t about vn. So this is a basic equation for the incremental shape of the Newmark beta method. So we can calculate directly of the incremental acceleration by delta f hat divided by m hat. M hat is the same m plus half c delta t plus k beta delta t squared. However, delta f hat is m delta agn plus 1, where is the incremental of the ground acceleration in n plus 1 step, and minus av vn and minus aa an, where av an are constants with k delta t and c delta t plus half k delta t squared. By calculating delta an plus 1, we can easily calculate n plus 1 by plus them with the an. And also we can calculate the vn plus 1 and d plus 1 with an incremental shape of the equation. Use this equation. Okay, this time let's try another thing differently. Say here, instead of Kn plus 1, we know somehow the restoring force will be Fn plus 1. We know it somehow, for example, is equals Kdn. However, this is for the case of nonlinear, we can calculate step-by-step force instead use constant Kdn. Here we know that only thing we need to solve is Vn plus 1, and we instead of Vn plus 1 into the equation, so we get something about n plus 1, where Fn plus 1 we already know. And put everything about n plus 1 in the left side of the equation, and put anything about Fn plus 1 in the right side, we can somehow get this equation. Thus, we can calculate n plus 1 easily. We calculate F hat, which is updated every step with already known Fn plus 1, and with m hat with m and half c delta t. Only the constant for AA is c delta t, and the constant for the Vn is c. Here I summarized all the three methods we explained until right now: numeric-based method, incremental type of numeric-based method, and using the restoring force method. You can see that if we use the restoring force, the equation becomes very easy, and somehow the result should be always the same. So please look at the figure and find out what is different between these three methods.